In this class, let us discuss the topic corrosion and its types. Corrosion. Corrosion is defined as gradual destruction of metals by chemicals or by the gases present in the atmosphere. So, when a metal is in contact with the atmosphere or when a metal is exposed to the atmosphere, chemicals present in the atmosphere or also the gases like hydrogen, nitrogen, oxygen, hydrogen sulfide, etc. in the atmosphere will come in contact with this metal and the metal gets destroyed, and that is called as corrosion. As a result of corrosion, various useful properties of the metal also get destroyed. And we all know the common example for corrosion is rusting of iron. When the metal iron is exposed to the atmosphere in presence of moisture, it undergoes corrosion, and the corrosion product formed is called rust, and the process is called rusting of iron. Why this corrosion occurs? Metals are normally extracted from their ores. Ores are the stable state of the metal, like chloride, sulfide, carbonates, etc. So, when these metals are extracted from their ores, they become unstable. That is, they will be in a high energy state. So they will always have the tendency to attain the stable state. So they want to form compounds with the chemicals or the gases present in the atmosphere. So the metals, they have the tendency to attain the stable state, and so they form compounds which leads to the corrosion of the metal. Types of corrosion. Corrosion can be broadly classified into two types based on the mechanism followed or in the environment. It is dry corrosion or wet corrosion. Dry corrosion means it takes place in absence of moisture. Wet corrosion takes place in presence of moisture. There are various types of dry corrosion as well as wet corrosion, which we can see it one by one. So first one is dry or chemical corrosion. Dry or chemical corrosion. Corrosion by gases like oxygen, hydrogen sulfide, etc. in absence of moisture is called dry corrosion. And this corrosion takes place only in the dry condition. So, let us study the mechanism followed in this dry corrosion. Consider the metal kept in an environment in absence of moisture, but in presence of gases like oxygen, hydrogen, etc. So, as a first step, the metal undergoes oxidation. That is, the metal loses its electrons and form metal ions. M gives M2 plus 2 electron. That's the oxidation process. So, these electrons transfer from the metal to the oxygen in the environment to form O2 minus ion, oxide ion. So, this oxide ion then combines with the metal ion to form the metal oxide, which is the corrosion product. So, this corrosion product will get settled on the metal at the corroded area. So, this metal oxide form will be present perpendicular to the metal surface, that is on the corroded area. So, that's the mechanism of dry corrosion. Types of dry corrosion. Based on the atmospheric gases involved in the corrosion, dry corrosion can be classified into many types. If the corrosion of the metals takes place by oxygen at high or low temperature, it is called oxidation corrosion. Alkali metals and alkaline earth metals normally undergo this type of corrosion even at very low temperatures. Almost all metals undergo corrosion at high temperature except silver, gold, platinum. They are the native state metals, noble metals, we all know that. Then if the corrosion takes place by hydrogen, then that is called as corrosion by hydrogen. And if the corrosion of the metals by hydrogen at high temperature, it leads to a process called decarburization, loss in carbon content of the steel because of this hydrogen. That's also the type of corrosion where the carbon content of the steel get decreased and thereby the property of the steel also decreases. So, and also hydrogen sulfide at ordinary temperature attacks the metal and makes it brittle in nature, lead to crack formation, etc. And that is called as hydrogen embrittlement. So these are the two types of corrosion by hydrogen. And the third type of dry corrosion is liquid metal corrosion. Liquid metal corrosion means when this type of corrosion takes place due to the molten state of the metal. When a metal is at very high temperature, it gets converted to its molten state. This molten state of the metal, when come in contact with some other metal, that metal gets corroded by this molten metal. That is called as liquid metal corrosion. Such type of corrosion occurs in power plants and in also industries. Nuclear power plants and industries which make use of the metals at high temperature faces this type of corrosion. Then, metal oxide, the corrosion product which is formed on this metal due to this dry corrosion may be protective, stable, unstable or non-protective. The protective and non-protective nature of the metal oxide formed can be understood, predicted from a rule called Fillings-Bedworth rule. So, according to this rule, if the volume of metal oxide formed is greater than volume of metal consumed, then that metal oxide layer is non-porous in nature. That is, as the metal oxide volume is greater and more, further gases cannot penetrate into that layer as its volume is more. Further gases means the atmospheric gases like oxygen, it cannot penetrate into this metal oxide layer, and so this oxide layer acts as a protective layer to the metal. And such type of metal oxides are formed in metals like tin and lead. If the volume of metal oxide formed is less than the volume of metal consumed, then that metal oxide layer is porous in nature. Gases can easily penetrate through it and it can attack the metal and further corrosion takes place. Such metal oxide layer is non-protective in nature. It is normally formed by metals like sodium, potassium, calcium, magnesium, etc. That is, and they are formed by alkali and alkaline earth metals. So the second type of corrosion, wet corrosion, it is also called as differential corrosion. So the wet corrosion occurs in presence of moisture or an electrolytic solution. So when a metal is kept in aqueous solution or in moisture, it undergoes corrosion, that is called as wet corrosion. So now let us see how this wet corrosion occurs. That is mechanism of wet corrosion. So in this type of corrosion, one part of the metal acts as anode and the other part of the metal acts as cathode. So we all know that at anode the metal undergoes oxidation to form metal ions, M2 plus ions. The loss of electrons, the metal forms metal ions. At cathode, based on the acidic or neutral environment system, Cathodic reaction varies. If the environment is acidic, then it leads to hydrogen evolution formation. And if it is a neutral environment, it leads to hydroxide ion formation. These cathodic ions combine with the metal ions and forms the corrosion product. And in this type of corrosion, the corrosion product is not formed on the corroded area, but this corrosion product is formed somewhat close to the corroded metal and not on the corroded area, as like in dry corrosion. So that is the mechanism of wet corrosion, more or less same as dry corrosion, but the only difference is the corrosion product is not formed on the corroded place of the metal, but some place far away from the corroded metal, somewhat close to the metal corroded area, but not in the corroded area. Okay, that's the mechanism of wet corrosion. Then let us see the types of wet corrosion. Wet corrosion is also classified into two types: galvanic corrosion and differential aeration corrosion. When two dissimilar metals, different metals, are in contact with each other, and these metals are placed in an atmosphere of moisture or aqueous solution of an electrolyte, galvanic corrosion takes place. That is, one metal undergoes corrosion and the next metal is protected. Other metal is protected, and the metal which undergoes corrosion has more negative electrode potential. The metals having more negative electrode potential will be more active and act as anode. And the metal part which acts as anode undergoes corrosion. So the metal which is having less negative reduction potential or positive reduction potential will be less active, and the less active metal means it acts as cathode and it will not undergo corrosion. So for example, let us see the zinc ion bimetallic coupled. Zinc metal, it has the potential minus 0.76 compared to the metal ion, which is positive, plus 0.34 volt. So the metal zinc having more negative reduction potential, it is more active and acts as anode and undergoes corrosion. That is the metal ion less active cathode, so it will not undergo corrosion. And this galvanic corrosion can also be minimized by placing insulators between the metals. If a proper insulating material is placed between the two metals, we can decrease this type of corrosion. So only in most of the cases, the bolt and nuts are made of same metal are preferred. If they are of different metals, they will undergo corrosion. And in the series, EMF series, if the metals are somewhat close, we can choose that two metals so that they will not undergo corrosion. Second type is differential aeration corrosion. So, when a metal is exposed to different concentration of electrolyte or oxygen, differential aeration corrosion occurs. That is, when a metal having different concentration of oxygen or its own electrolyte, corrosion takes place in one part of the metal. So the metal part which is in contact with the solution or if the moisture, it undergoes corrosion because the part of the metal which is in contact with solution has less amount of oxygen, less aerated part, and it acts as anode and undergoes corrosion. So the metal part which is not in contact with this solution or moisture is more aerated and it acts as cathode and will not undergo corrosion. For example, let us see the zinc metal partially immersed in sodium chloride solution. So the metal part which is not in this NaCl solution is more aerated, act as cathode and no corrosion takes place there. And so the area, the metal part immersed in solution, less aerated, acts as anode and undergoes corrosion. So such type of corrosion is also called as waterline corrosion, normally seen in the bridges, pipelines, wire fences, etc. We can see such a type of corrosions. So their corrosions are called as pipeline corrosion, wire fence corrosion, pitting corrosion. So this pitting corrosion, wire fence corrosion, pipeline corrosion are the different types or the various examples for differential aeration corrosion. The metal part which is more aerated act as cathode and will not undergo corrosion. And the metal part which is less aerated act as anode undergoes corrosion. That can be seen in all these examples. In pitting corrosion also you can see that. And the metal part containing a droplet of water. And this water drop area is less aerated. And that acts as anode and that part of the metal undergoes corrosion. And in pipeline corrosion also you can see that when the pipeline passes from clay area to sand area, the corrosion takes place at the clay area than the sand area because clay is tightly packed. The soil is tightly packed there, so it is less aerated, whereas in sand area it is more aerated. So the corrosion takes place at the clay area. In this last example, fence corrosion, wire fence corrosion, the cross of the fences, wire fences, it is less aerated compared to the area which is exposed to oxygen. And this area acts as cathode, it will not undergo corrosion. But the fence area which is crossed together, it acts as anode and it undergoes corrosion. So by this slides, we got an idea about corrosion and its types.